Hello. Hello. Hello.
கேக்குதா? சரி, தமிழ் தெரியாது. Sir, can you hear me? தெரியல. Sir, can you hear me?
Yeah, good afternoon. How are you? I can hear you.
Yes, sir.
So am I clearly audible?
Yes, sir.
Okay. So shall we start?
Yes, sir.
Okay, so can you let me know that why we have reached last time in the last lecture?
Electromagnetic wave theory.
Yeah, electromagnetic wave theory, right. So have we discussed the properties or the characteristics of a wave? That means the wavelength, frequency, wave number. Have we discussed that?
Yes, sir. Yes, sir.
Okay. So I think that we have also then discussed the relationship between the frequency, wavelength, right?
Yes, sir. That formula C is equal to lambda into nu. That.
So let's move ahead in this electromagnetic wave theory, and we will also today solve some numerical type questions, and I hope that you can solve those. So in this electromagnetic wave theory, first of all, you will remember that this electromagnetic wave theory, it was just given by James Clerk Maxwell, and it states that any electromagnetic radiation, it has wave nature, right? So that means it travels in the form of wave, and wave is always delocalized, it is always continuous. And whenever we have different waves, that means they will differ in their wavelength or frequency, right? Their speed is always constant, that is the same as that of light, that is 3 into 10 raised to power 8 meter per second, right? Okay, so that means if we just know the frequency, we can calculate the wavelength, and similarly, if we just know the wavelength, we can calculate the frequency. Then let's see the different types of electromagnetic radiations, what we called as electromagnetic spectrum. Are you all attentive?
Yes, sir.
Okay, let me share the screen here. Now here, let's see first of all, what is this electromagnetic spectrum? So is the screen visible clearly?
Yes, sir.
Electromagnetic spectrum. So it is just simply we are having different electromagnetic radiations, and when they are actually arranged in increasing order of their wavelength, we just call it as electromagnetic spectrum. So simply you will write it here that here what we do, electromagnetic radiations, that's EMR, electromagnetic radiations are arranged in, they are just arranged in increasing order of, they are arranged in increasing order of wavelength. So I hope you remember this wavelength. It is just one of the property of a wave, that is simply it is the distance between the two consecutive crests or the two consecutive troughs, right? Okay, so now we are having different electromagnetic radiations. So let's see one by one. First of all, we are having the gamma rays. Gamma rays have a very low wavelength. That means they have very short wavelength. After gamma rays, we are having then the X-rays. X-rays are having higher wavelength than the gamma rays. Then we are having the UV rays, that is the ultraviolet radiations. And then we are having the visible spectrum, that is the visible rays. And then we are having the next, that is your infrared radiations, that is your IR rays. And the next one is your microwaves. And then we are having the radio waves. So in radio wave, we can have short and long radio waves. So this constitutes our electromagnetic spectrum. So you have to remember that our electromagnetic spectrum, it consists of various electromagnetic radiations, and they are just arranged in increasing order of wavelength. So that means the highest wavelength, it will be possessed by these radio waves. So that means when you just move from this gamma ray here, and you are moving towards this radio wave, so that means highest wavelength will be possessed by these radio waves, and the shortest wavelength, it will be possessed by gamma rays, right? Now, another very important and interesting thing here is that when we move from gamma rays towards the radio waves, what will happen to the frequency? I hope you can answer this. What will
So
happen?
radio waves will be more and gamma rays will be, no, gamma rays will be more and radio waves will be less.
Exactly, because we know that frequency and wavelength, they are inversely proportional to each other. So frequency will be here very less in case of radio waves, and here in case of gamma rays, they will have very high frequency, right? Now, another very important point to be remembered here, to be noted down here, that is very important, that is the about energy. So can you tell me what will happen to the energy when you will move from gamma rays towards the radio waves? Can anybody tell me? What will happen to the energy? So you will remember that energy also decreases. Energy will be very less in case of radio waves, and highest energy will be possessed by these gamma rays. These 3 points are very, very important here. I hope you will remember that when you just move from gamma rays towards the radio waves, what happens? Wavelength increases, frequency decreases, and the energy also decreases. So that means very high energy will be possessed by the gamma rays. So if question is asked that which of these electromagnetic radiations will be highly dangerous, so can you tell me which one? Highly dangerous. Dangerous is that means which has very high energy. So which is having very high energy?
Gamma rays.
Exactly. So that's why they are very much dangerous. For example, okay, I will just give one of the example. For example, if UV rays, ultraviolet radiations, they just come to the surface of Earth, what will happen? Eye cataracts will take place. There will be skin cancer. There will be a reduction in the growth of plants. Aquatic life will be affected by these UV rays. That means they are very harmful. So that means gamma X-rays, they are more harmful. And similarly, gamma rays, they are very harmful because they have very high energy. They can destroy the nucleus of cell. So this is very important. You will remember the order of their wavelength, the order of their frequency, and the order of their energy. So any doubt here? So can you now tell me which is having very high energy? Is it visible ray or IR ray? Energy. Yes.
Sir, can you repeat again?
See, visible ray, it will have very high energy as compared to this IR ray, because I told that when we just actually move from gamma ray towards the radio waves, what happens? Energy decreases. Radio waves have very low energy. They have low energy. So highest energy is possessed by these gamma rays. So that means visible rays, they will have high energy as compared to infrared radiations. Correct?
Yes, sir.
Okay, next very important is that this visible ray, actually this is visible spectrum. It further consists of 7 different colors. I hope you remember those. They are actually your VIB, right? VIB, GY, O and R, right? VIB. So this is your violet color, then indigo, then blue, then green, yellow, orange, and red. So can you tell me their wavelength? What will happen to the wavelength when you will just move from violet towards the red?
Red has more wavelength.
Exactly, wavelength increases. As I already told that when you move from left to right, wavelength increases. Okay, what will happen to the frequency? Frequency will decrease, right? When you
Yes,
just
sir.
move from violet to the red, what will happen to the wavelength? Wavelength increases, but what will happen to the frequency? Frequency will decrease. And what will happen to the energy? Energy will also decrease, because you will remember, we will actually see ahead that we are having one of the important theory, that is the Planck's quantum theory, that actually says that energy is directly proportional to the frequency. So if frequency decreases, that means energy will also decrease. So have you got it now? This is very, very important. You should be able to know, you should be able to differentiate between the energy, the wavelength, and the frequency of various electromagnetic radiations. All these are electromagnetic radiations, whether it is gamma ray, whether it is X-ray, whether it is UV ray, whether it is visible light, whether it is IR radiation. All these are electromagnetic radiation. And similarly, in case of this visible spectrum, we are having 7 different colors. That's your VIB. And among these, red has very low energy. That means high energy will be possessed by violet color, right? And similarly, its frequency will be also high, because higher the frequency, higher will be the energy. You will note down this point, that if frequency is very high, then energy will also be very high, right? And similarly, wavelength, it is inversely proportional to the frequency. Wavelength is inversely proportional to the frequency. So that means if frequency is low, wavelength will be very high. So that means in case of violet, frequency is high. So that means wavelength will be low. Got it? It will have very short wavelength. So this is your electromagnetic spectrum. I hope you have noted down this. Have you noted down this? Just write down this. These are the 3 very important characteristics of any electromagnetic radiation. That's your wavelength, the frequency, and the energy. So have you noted down this? Stage, have you noted down? Have you completed?
Yes, sir.
Okay. So let me show actually here that I'm having one of the pic here. You can see this electromagnetic spectrum here. I will share it with you. That's actually shown on your also the text. So is it visible? Is it visible?
It is visible, sir.
Okay. So tell me here that in this, what you see actually. So this is your visible spectrum. This is your visible spectrum. You can see here, we are first having here violet color, right? It starts from this violet, right? And then when we just move here towards the red color, right? VIB. isn't it? You are having V, I, B, G, Y, O, and R, right? So this is your waveguide. Okay, now you can see here the colors, and you can also see here the wavelength. So I just told that when you just move from gamma ray, so this is my gamma ray, right? This is my gamma ray, you can see here. Then it is the X-ray, then it is the ultraviolet radiation, then infrared, then microwave, then it is your radio wave. Now in radio wave, I hope that you have heard in case of radio, we are having FM band, we are having AM band. So what are these? These are actually the different frequencies, FM, AM, similarly long radio waves. Now you can see that when you just move from gamma ray is having how much wavelength? It is 10 raised power minus 16 meter. That means it is very small wavelength. It is minus 16. Then when you just come here, long radio waves, it is 10 raised power here, 8 or 10 raised power 6. So that means it is having very high wavelength. So wavelength increases when you just move from left to right in the spectrum. Similarly, what will happen to the frequency? Frequency will decrease. Frequency will decrease. So you can see here, it is 10 raised power plus 24. Gamma rays are having frequency 10 raised power plus 24. So that means bigger value, very high frequency they are having. And when you just move towards the radio waves, it is here, you can see 10 raised power 0, then 10 raised power 4, isn't it? 10 raised power 6, 4, 10 raised power 2, 10 raised power 0. So yes? Are you having any doubt?
No, sir.
Okay, so that means frequency is very less in case of radio waves. And if we just talk of energy, so energy, what will happen when we move from gamma ray towards the radio waves? Energy will also decrease, correct? Energy will also decrease. Have you got it? Is it clear?
Yes, sir.
Okay, now see here, in case of this visible spectrum, that means violet. Violet is having how much wavelength? It is having 400 nanometer. It is in nanometers, so you will remember it. It is 400 nm, nanometer. And this red, it is having wavelength 750 nanometer. So that means wavelength, it also increases from violet towards the red. And similarly, frequency will decrease and energy will also increase. So that means violet color, it is having very high energy, and red color, it is having very low energy. So have you got it now? Any doubt here?
No doubt, sir.
Okay, so let's move towards the next. I will just share the screen again here. If you have any doubt, if there is any other technical issue, you let me know at that time.
Sir, we were just checking on the spectrum that this
Yeah.
Meghna girl drew. She was copying, so only, sir.
What she was doing?
She was copying the spectrum, sir. So we were just seeing.
Okay, shall I again share it?
No, sir, it's okay. You can continue.
It is also available on your NCERT textbook. You can just see it there.
But she thought that you were showing something different, so she copied everything.
Okay, no problem. Do you know that when I just take your class, I'm just also saving these pages at the end. I will share these with you, right? I will just share with
Okay, sir.
Bhaskar sir, then he will also share with you. Okay.
Okay, sir.
So you have not to worry about the notes. You have to just understand each and every point, and you should be able to just solve the numerical portion questions, right?
Okay, sir.
Yeah. If there is any confusion, you can let it know to me. Okay, let
Okay,
me
sir.
share it again. So now we know the formula, right? What is the formula? What is the relationship between the speed and the frequency and the wavelength? That is C is equal to nu into lambda, correct? Have we studied this? Yes.
Yes, sir.
And similar, we have already also studied that wave number. Wave number is always equal to 1 upon lambda, correct? And we have also seen that frequency is also equal to 1 upon time period. So I hope you remember these three very simple formulas, isn't it? Okay, so that means if I have to just calculate the frequency, so that means it will be simply equal to C by lambda. Okay, then there is one question on your textbook and on your NCRT textbook, that is, you have to just, it is given that there is Vivid Bharati station, Vivid Bharati station, and it is just giving, there is a electromagnetic radiation which is having frequency is given to you. I think it is 1368 kilohertz, right? You can check it on your NCRT textbook, it is given there. And what you have to calculate, you have to calculate its wavelength, and you have to also tell that in which spectrum it will lie. So can you calculate here the wavelength? I hope you can do this question. Now the first thing is here that frequency is to be converted. It is here given in kilohertz, KHZ. So it is your 1368 kilohertz. So can you tell me
3 into 10 power 3.
exactly? 1 kilo is 10 raised power 3. So you will just write it 1368 into 10 raised power 3 hertz. Correct? Okay. Tell me also that what is this hertz? What you can also write in place of this hertz?
Second minus 1 per second.
Exactly. That is known as per second. Second inverse, or you can call it as per second. So both are correct. Whether you write it as hertz, HZ, or whether you write it as per second. So both are correct. Now tell me how to calculate the frequency, how to calculate the wavelength. So it is now simple that wavelength is equal to C by nu. And what is C? C is the speed of electromagnetic radiation. That is always constant. That is 3 into 10 raised power 8 meter per second, right?
Yes, sir.
So you will just divide it with 1368 into 10 raised power 3 per second. So what will here happen? What will get cancelled here in case of units? First, just cancel the units. So per second, it will cancel. So we will only be left with meter. So because we are having wavelength, so its answer will be in meters, right? Is it clear?
Yes, sir.
Okay, then I can also write it as 3 by 3 over 1368. Now see, it is 10 raised power 8, and it was here 10 raised power plus 3. When it will come above, it will become 10 raised power minus 3, right? Now, how to solve this? How you can divide 3 by 1368? It's a very big number, so you will just convert it into smaller number. So how to calculate it? How to convert it into smaller number? So if I just write 1368, can I write it that it is equal to 13.68 into 10 raised power plus 2? Can I write it like this? I hope you have studied it in the mathematical tools, in the physics also, and also in the mole concept in the first chapter of chemistry. So can I write it like this? Are you having any doubt here? I wrote that in place of 1368, I can write 13.68 into 10 raised power 2. Can I write like this? Can I write like this? It is 13.68 into 10 raised power 2. See, you can again multiply it. It is 13.68 into 10 raised power 2 means 100. So when you just multiply it by 100, it will again become 1368. So that means I can write like, right? Have you got it?
Yes, sir.
It's very simple. You will just remember that if you are having a bigger number, you can just convert it into smaller one, scientific number. It is the basic. I hope that you have gone through this. Okay, I will again tell it. See, it is 1368. Now what I did, I just make it small. I make it 13.68. So that means after decimal, there are two terms. That is after point, there are 268, two terms, right? So that means 10 raised power 2. Power will be here 2. So now what I will write here, I will just write it 3 over 13.68. So then you will just write here 10 raised power 2, so that when 10 raised power 2 comes up, so what it will become? It will become 10 raised power minus 2. Have you got it? Now it is very easy that 3 ones are 3, 3 fours are 12. That means 4 point something it will come. You have to just calculate the approximate answer. It is not, whenever there is any competitive exam, you have not to calculate the exact answer. You have to just calculate the approximate answer. You have not to use any calculator, right? Okay. So it is now just 1 by 4. You can simply write 1 by 4. You can neglect other decimal, other fractions. So 1 by 4. So that's how much? 1 by 4. So that means 0.22 something, right? 0.22. Okay. Into 10 raised power. Now it is here 10 raised power minus 3 and minus 2. That is minus 5 and plus 8. So that is 10 raised power 3. So got it? Any doubt
Sir.
here?
No doubt, sir.
Okay. So now what you can just approximately write it as it is 2.2, 2.2. That means it was here 0.22, that is smaller number. Now you have made it a bigger number, that is 2.2. So that is, you will write 10 raised power 2. Power will decrease here. So that means you can now, it is 2.2 into 10 raised power 2. 10 raised power 2 means 100. So when you just multiply 2.2 into 100, so that's your 220 meter, correct? 220 meter. So that means it will just lie in the radio wave, because radio waves have this range of wavelength. Is it clear?
Yes, sir.
Okay, so have you written down this? Shall I move to the next page?
Yes, sir.
Okay. Now tell me here, you are having just violet color. Now its wavelength is given to you. How much it was? It was 400 nanometer, right? So can you calculate its frequency? So you have to try. First of all, try yourself. What will be its frequency? So can you solve this one? It is now very easy. You know that frequency is always equal to C by lambda, isn't it? Nu is always equal to C by lambda. So C is, you already know it is always constant. So that is 3 into 10 raised power 8 meter per second, correct? And you have to divide it by the wavelength. So wavelength is 400 nanometers. So first convert it into meters. So it is 400 into 1 nanometer is how much? Ratika, can you tell me? 1 nanometer is how much?
Sir, 10 to the power minus 10.
It is 10 to the power minus 9 meter. Nano means 9. 10 to the power minus 9 meter. Got it?
Sir.
Okay. Now tell me that if I just write what I can write in terms of.
Sir.
Okay.
Sir,
Tell me.
sir, is it 7.5 into 10 to the power 16?
Okay, let's solve it. Then let's check your answer. So it is, can I write 404 into 10 raised power 2? Can I write it like this? Can I write it like this?
Yes,
In
sir.
place of 400, I have just written 4 into 10 raised power 2. I can just write 4 into 10 raised power 2. I can write it like, okay, when bases are same, power should be added. So it will be 4 into, now it is 10 raised power minus 9. Here it's plus 2. So it will be 10 raised power minus 7 meter, correct? Okay, just divide it here. So it is 4 into 10 raised power minus 7 meter. I told you that you have not to calculate the actual answer. You just try to calculate the approximate answer, because you have to face ahead the competitive exam, like any competitive exam, like you are having the NEET, JEE, Mains, etc. In that case, you have not to calculate the actual answer. You have always to calculate the approximate. So meter here, it will get cancelled. So answer will be in per second. So I hope you can now solve this. It is now very easy. So it is now 3 by 4, 3 by 4. Now it is 10 raised power 8. Keep it as such. So it is 10 raised power minus 7. When it will just come up, it will become plus 7. Correct? So when base are same, power should be added. So it will be 10 raised power 15. Correct? And now 3 by 4. So it is now easy to divide 3 by 4. So it will just come out to be 0.7,
75, sir.
0.7. Right?
75. 0.75.
Yes, sir. Exactly 0.75. Okay, approximate. You have to calculate it. So now how you can write it? Can you write it 7.5 into 10 raised power? So it was small. I have make it big. So that means here power will decrease. So it will become 10 raised power 14 per second. Got it? You can also write it like this. That is 75 into 10 to the power 13 per second. So what is the trick here? What you have to remember here? You have to just remember that, see, it was 0.75. That means it was a small number, isn't it? Now you have written here 7.5. So that means it is a big number. So when here it is small and you are making it big, then power will decrease. It was 15, now it is here 14. Similarly, it was 7.5, smaller. Now here it is 75, that is bigger number. So that means power will further decrease. So it will be 10 raised to power 13 per second. So is anybody having doubt here? Is it clear to all of you? Is it clear to all of you? Is it clear to all of you?
Yes, sir.
Okay, so if I just give you some number and you have to just convert it into scientific number, so can you do it? For example, okay, tell me, okay, Meghna will tell me that if I'm having, let's say, I'm having 5,000. So how you will write it into scientific number? 500. So can you tell me?
Sir, 5 into 10 to the power 2. Minus 2 to 2 to 2.
5,000 I told, right?
Sir,
So
can,
5,000 can be written as 5 into 10 raised power plus 3, right?
yes, sir.
Okay. But tell me that if I am having 0.05, how I can write it if I will just write 5? 5 into 10 raised power?
Sir, minus 2.
Exactly, minus 2. Correct. Okay, I hope that you can do it, right? You can do the conversion. It's very easy. Okay, then let's move ahead. Then we have to actually study here. So I hope that you can calculate the frequency, the wavelength, the wave number, correct? Okay, okay, I will tell you the question that you have to calculate wave number. So what is wave number? That is your new bar. Calculate new bar. If time period is 10 raised power 2 second. So can you solve this question? What you had to calculate? You had to calculate the wave number. So wave number is always equal to 1 by lambda, isn't it? 1 by wavelength, correct? So that means you should first know the wavelength, then you can calculate the new bar, that is the wave number. So what is wavelength? Wavelength is equal to C by nu. That means if you just want to calculate the wavelength, then you should know the frequency. But here frequency is also not given, time period is given. But you also know that frequency is always equal to 1 upon time period, correct? So now it is very simple to solve. So you had to first calculate the frequency. So frequency is 1 by time period. Time period is given, it is 10 raised power 2 second. So when 10 raised power 2, it will just come up. You will write it as 10 raised power minus 2. So it was second, it will now become per second, correct? Got it? Okay, so this is the frequency. Then
Yes,
you have
sir.
calculated. Yeah, then it's the wavelength. Wavelength, it is now very easy. So that is 3 into 10 raised power 8 meter per second. And you will just divide it by frequency. Frequency is how much? It is 10 to the power minus 2 per second. So just here per second and per second, it will cancel. First, just cancel the units. If units are correct, then your question is also going to be correct. So tell me here, it is now unit meter left because wavelength should be in meters. So I will just write it that it will be now 3 into, see, it is 10 raised power minus 2. When it will just come up, it will become plus 2. And when base R sum power should be added, so it will become 3 into 10 raised power 10 meter. Have you all got this? Because this is very important here. I hope you have got it. Right? Any doubt here?
No doubt, sir.
Okay, there are also some participants from here. That is Ananya and Arvintha. So
Yes,
are
sir,
you getting?
I'm here. I'm here, sir.
Okay. So then let's see, move ahead. So what we had calculate next? Next we had calculate. Next, what we had calculate? Wave number, right? So wave number is equal to 1 by lambda. So 1 upon lambda. Lambda is here. That is 3 into 10 raised power 10 m. So what it will be? It will be just 1 by 3. So it was 10 raised power plus 10. When it will just come up, it will become 10 raised power minus 10 meter, isn't it? So when you just divide 1 by 3, so it will just come out to be 0.33 into 10 raised power minus 10. Now it will become meter inverse because it was here in divide meter. When it will just come up, it will become meter inverse because this is now a wave number. Wave number, its unit will be meter inverse. So got it? So we have calculated the frequency, the wavelength, and also the wave number. So I hope that you can solve such type of questions, right? Have you written down this? Have you noted down this?
Sir, will this be 3.3 into 10 power minus 9?
Okay, see, now it is 0.33. That means it is smaller number. When you will just make it bigger, that means when you just write 3.3, so that means power will decrease. Okay, I
Okay,
will
so
write
10
what
power
is
minus 11. 10 power minus 11. Then.
exactly. So you can write the wave number finally as 3.3 into 10 raised power minus 11 meter inverse because minus 11 is smaller. And similarly, if you just write it 33, then what will be the power?
Minus 12.
Exactly. So is it clear now? Is it okay? Have you got it now?
Yes, sir. Yes, sir.
Okay, so let's move ahead. So we have discussed the wave nature, that is the electromagnetic wave theory. Now the next we have to study the
Sir, can you
optical
show the
nature.
previous slide 1 second?
Okay, sure. I will show the previous slide. So this is the previous.
Sir, you can continue.
Okay, sure. So we have discussed this. Now the next we have studied the particle nature of electromagnetic radiation, right? Wave nature we have studied, but along with that, electromagnetic radiations have also the particle nature. So let's see the particle nature of electromagnetic radiations. See, actually, when we say that any electromagnetic radiation, it has wave nature, we can explain some phenomena, but we're also having some phenomena which cannot be explained by the wave nature. So that is why it was just told that there is also the particle nature of electromagnetic radiation. So this particle nature of electromagnetic radiation, it is actually understood from some phenomena which we have to study here. Number first phenomena which we will study, that is the very important, that is known as black body radiation, correct? Black body radiation. So do you know what is a black body? Black body radiation. So can anybody tell me what is a black body? See, you had to remember that black body doesn't mean its color is black. Black body actually means that
Absorbs all the radiation.
exactly any such body which absorbs or emits radiations of all wavelengths, or we can say radiations of all frequency. So that is called a black body. So I will just write it here, that black body is such a body which absorbs or emits radiations of all wavelengths, or you can say all frequencies, radiations of all wavelengths, or what you call it as frequencies, right? All frequencies. So if we are having any body which can just absorb all types of radiations, that means radiations of all wavelengths, or you can say radiations of all frequency. So we call such bodies as black bodies. But there isn't any such body which is 100% black. There isn't any such body. Just have you known about the noble gaze, ideal gaze and non-ideal gaze? Have you the concept of the ideal and non-ideal gaze? Okay, I will write it here, that there is no any such body which is 100% black. There is no any such body, no any such body which is 100% black. So have you got it, this point? So that means there isn't any such ideal black body. That means which can just absorb all types of radiations having different wavelengths, and similarly which can emit all the radiations of different wavelengths or frequencies. So that means this black body, it is just an ideal, it is just a theoretical concept. But there is, I can just give you the example of a black body. Just we are having the lamp black. It is nearly 100%, but not completely 100%, but it is treated as 99% black body. That means it can just absorb all the radiations of all types of wavelengths. It can emit and absorb all types of radiations. So this is your one of the black body. So similarly, sun, you are having, sun is just also a black body. It can just emit various radiation, isn't it? We are having different types of radiations coming from the sun, like gamma ray, X-ray, UV ray, visible light, infrared radiations, right? They are just coming from the sun. So that means sun can emit radiations of different wavelengths, not all, but almost various radiations. So we can say this is a black body. So any body which can just emit or absorb radiations of all wavelengths, that's called a black body. Now this radiation emitted or absorbed, this is known as black body radiation, correct? Isn't it? Okay, now let me give one of the very important observation here, which is experimentally found here. That is, tell me that if I'm having just an iron rod, so have you seen that when this iron rod is heated, what actually happens? So let's say this is my rod of iron. It's my iron rod. So when it is just heated, if it is heated, so can you tell me what its color becomes first? Its color first becomes dull red, right? And then it becomes red completely. And when you just further heat it, so can you tell me what color it's?
Sir, it'll fade away. So like orange, then I think white it
Exactly.
will,
After red, it becomes just orange, and then
I
it
think it
becomes
becomes
yellow.
then white.
Exactly. Then it becomes white also. And then if you further heat it, it can also become blue. So that means this iron rod, it just changed its color. So this was very important observation to be noted down here, that why actually it happens if we are just hitting an iron rod. According to the wave nature, that is the electromagnetic wave theory, its color should be only one single. It should obtain only one color, but it changes its color. That means it first becomes dull red, then orange, then yellow, then white, then blue. So why it is so? If you further heat it, it can also become violet. If you further heat it, it can also become violet, right? So why actually it is happening? So its answer could not be obtained from the electromagnetic wave theory. So that is why we are also saying that this electromagnetic radiation is actually having the particle nature. So, okay, if I will just plot a graph, have you noted down this? Shall I move to the next page?
Yes, sir.
Okay. So for example, tell me that if I'm just going to plot a graph here between the intensity of color, I'm just plotting a graph between the intensity versus the wavelength or the frequency. Now tell me, or you can just see here the temperature. If you are just increasing the temperature here, what type of graph we get here? We get this type of graph here. So what you can here observe that, see, first of all, when you just heat it, when you just increase the temperature, okay, you can also plot here the temperature. When you just increase the temperature, first intensity increases. Actually, I told that when iron rod it is just heated, it first becomes dull red. Dull red means its intensity, or you can just, if you are not getting this term intensity, you can just simply say the brightness. Brightness increases with increase in the temperature, but after some time, this intensity it decreases. Intensity again decreases. You can see it from this graph that intensity again decreases, isn't it? So that means actually you are first having the red color, and then it actually gets then converted into the orange, and then similarly yellow, then white, and then blue, and it can also become violet if you give very much heat energy to this iron rod. But why actually it happens, it cannot be explained from the wave nature, from the electromagnetic wave theory. So that's why we are having the particle nature of electromagnetic radiation. That is why we are actually given another theory that is known as Planck's quantum theory. Planck's quantum theory is very important, that actually explains that these electromagnetic radiations, they have particle nature. But before discussing the particle Planck's quantum theory, we will also study another important phenomena that is known as photoelectric effect. Photoelectric effect. We have just studied what is black body radiation. Now let's see what is photoelectric effect. This is very important topic. It is asked in the exam, so I hope you will remember this. So this photoelectric effect, it was actually studied by, it was actually observed experimentally by Hertz. That is actually also the unit of frequency, Hertz, at Hertz, isn't it? It is perhaps the talk of 1887. So Hertz, what he observed that if some light is fallen down on the metal surface, what happens? Electrons get ejected. That means electrons get ejected when light falls on some metal surface. So that ejection of electrons from the metal surface when light falls on it, it is known as photoelectric effect. So let me write it down here. It is the phenomena of, it is the phenomena of ejection of electrons. It is the phenomena of ejection of electrons from the metal surface from the metal surface when light falls on it. When light falls on it. So actually what Hertz did here, that's very important. He just took the two electrodes. One was the anode, another was the cathode. I hope you remember those electrodes, right? In a glass tube was here, just like this. Now this is the negative pole. That means it is just connected to the negative terminal of the battery here. It's just connected to the negative terminal of the battery here. And this is actually here the detector. This is actually here the detector. Actually, this negative pole, this is just your cathode, isn't it? This negative pole, it is simply your cathode. And this detector, it is just connected to the positive terminal of the battery. So this detector, it is just acting as your anode. So you can just connect it here to this battery. So here we are having this as a battery, right? Okay. Now tell me, what was here done? Light was just followed on this metal surface, that means on this cathode. So light can easily pass through this glass. So when it enters into this tube, into this glass tube, and it, as soon as light falls on this metal surface, so this is my cathode, that is my metal surface here. So when light falls on this, what was observed by this Hertz, that electrons get ejected. Yeah, exactly. Electrons get ejected and they move towards this detector, that is the anode. And it was just shown here by the deflection shown by the voltmeter or the galvanometer. You can just have here the voltmeter V. So this is your voltmeter here. And this shows the deflection. So deflection indicates that there is actually flow of current, that is the flow of electrons. So this effect was known as photoelectric effect. Photo simply means here light, right? And just electric effect, that means actually electric current is produced when light falls on this metal surface. So this was known as photoelectric effect. Now why actually it happens? What is the reason? Why electrons get ejected? What will be their kinetic energy? How many electrons will get ejected? Each and everything we have to actually note down here. So there were some observations which were observed by this Hertz. Let's see those observations. So can you tell me how you noted down this? Shall I move to the next page?
Yes, sir.
Okay. So just remember here that in this photoelectric effect, the number first point to be noted down, that is, as soon as light falls on the metal surface, electrons are ejected. So that means there is no time lag. So I will write it here that as soon as light falls, as soon as light falls on the metal surface, electrons are ejected. Correct? So it means that there is no time lag. So you can just write that there is no time lag. So what do you mean by this? No time lag. So that means as soon as light falls on the metal surface, electrons get ejected. So that means there isn't any time needed for this phenomena to occur. It just occurs as soon as light falls on the metal surface, electrons get ejected. There is no time lag. Okay, so the next very important observation which was observed here, that is the kinetic energy of ejected electrons kinetic energy of ejected electrons, kinetic energy of ejected electrons is directly proportional. Kinetic energy of ejected electrons is directly proportional to the frequency of light. So that means if frequency of light is very high, that means kinetic energy of ejected electrons will also be very high, isn't it? So this is very important that you have to remember that this kinetic energy, it is just directly proportional to the frequency. That is new. Got it? Okay. Next very important observation which was here observed, that is the number of ejected electrons depends on number of ejected electrons. Number of ejected electrons depends on intensity of light. So it depends on intensity of light. So if intensity is very high, brightness is very high, that means number of ejected electrons will be more. So it depends on intensity, or you can also call it as brightness, intensity or brightness of light. And it does not depend on the frequency. So that means how many electrons are actually getting here ejected. It doesn't depend on the frequency. It just depends on the intensity, or you can say the brightness of light. This was a very important observation. I hope you will remember these 2 points. One is the kinetic energy, another is the number of ejected electrons. So more the frequency of light, more will be the kinetic energy of the ejected electrons, and more the intensity, or you can say the brightness of light, more will be the number of ejected electrons. Got it? It's very important. So that means the number of ejected electrons, it doesn't depend on the frequency. It doesn't depend on the wavelength. It simply depends on the brightness, or you can say the intensity. So have you noted down this? Shall I move to the next page?
Yes, sir.
Okay, so we can see this now graphically. For example, if we just plot a graph here, let's say this is my graph. Okay, there was actually one more point.
Sir, I have a doubt.
Tell me.
How do you find if intensity of the light is high or low? Like if everyday red and blue, which will you say is higher?
Okay, it is very easy to tell. I just told that when iron rod is heated, it first becomes dull red. Dull red means its intensity is low. And when brightness of color increases, so that means its intensity will be high. For example, if you have two red colors, but one is dim red, another is very bright red. So which will have more intensity? The bright
Right.
one. Exactly. Similarly, if you have two green colors, one is dark green, another is bright green. So which will have high intensity? Bright one. So it is easy. So got it?
So will white light emit the most of electrons?
Now we are, see, white color, we are also having different variations. For example, if you just check your notebook, the pages of the notebook, some notebook are having very bright white pages, but some are having creamy white, some are having dark white. So that means intensity varies. It is not having same intensity. It varies. Correct? Okay. So have you got it?
Yes, sir. Yes.
Okay. Now next point was that electrons are only ejected when electromagnetic radiation, that is light, has some minimum frequency that was known as threshold frequency. So I will write it here. The fourth point, next point, electrons are ejected only. Electrons are ejected only when light has, that means electromagnetic radiation has, because light is also your electromagnetic radiation. Light has some minimum frequency. Light has some minimum frequency. And what is that frequency known as? Known as threshold frequency. This is very important term to be noted down here, threshold frequency. And it is just represented by nu naught. Nu naught is known as threshold frequency. So that means every light cannot eject electrons. Only that light will eject electrons which has some sufficient frequency, and that minimum sufficient frequency, that is known as threshold frequency. Got it? So now if I will just plot a graph, okay, tell me that if I am just plotting a graph between the kinetic energy and the frequency. So can you tell me what type of graph shall I get here? Graph is very important. It's asked in the exam. So what we saw in the previous slide, I told
Linear graph.
exactly it will be linear, but will it be starting from the origin or not from the origin? Will I start it from this origin initial point, or here or here? For example, okay, I will write, let's say frequency here it is 0, then let's say here it is, let's say 1, let's say here it is 2, any value you can give, let's say 3, 4, 5. So actually graph, it starts from here. It is straight, but it is just starting from here, not from the origin, not from the origin. So can you tell me why? Can you tell me why? It is just starting from,
Sir,
not
because
from the origin.
it needs minimum frequency to.
Exactly, it needs some minimum frequency, and that minimum frequency, that is called the threshold frequency, that is represented by nu naught, right? Nu naught. So you have to remember it. I hope you have got this. Okay, it is just like this. Okay, I will make it straight. It is just like this straight line, but it will not start from the origin. So have you got it now? This graph is asked in the exam. Sometimes graph will be given to you and you have to tell that is it correct graph, or which of the following represents the correct relationship between the kinetic energy and the frequency, correct? So I hope you can draw it. Can you draw? It's very easy, because I told that electrons are ejected only when light has some minimum frequency, and that frequency, minimum frequency, that's called the threshold frequency. Okay, now tell me if I will just have another graph here. That is, if I am just plotting a graph between this kinetic energy versus the intensity of light. So what will be the graph? So can anybody tell me what type of graph we will get here? Because it's very important. So I told that kinetic energy of ejected electrons, that actually depends on the frequency, but that doesn't depend on the intensity. So that means graph will be straight parallel to this intensity axis. Got it? This graph will be very important. It is actually asked in the exam. So that means that means the kinetic energy, it will remain same. Kinetic energy, it will just remain same. I'm just showing the dots here. That means they are lying on the same line. So if you are just changing the intensity, let's say here the value is 1, let's say here 2, 3, 4, etc. So if you are just changing the intensity, the kinetic energy will not change. Kinetic energy will only change if you are just changing the frequency. This is very important. Got it? There are 4 important points. I will just revise or repeat. Number first was that electrons are ejected as soon as light falls on the metal surface. So that means there is no any time lag. Next point, I told that the kinetic energy of the ejected electrons, it depends on the frequency, not the intensity. It depends on the frequency. And the number of ejected electrons, that depends on the intensity or the brightness of light. And similarly, electrons are ejected only when light has some minimum frequency, that is known as threshold frequency. So is it now okay? Have you got it? Any doubt, any confusion here? I think there shouldn't be any confusion, right?
Yes.
Shall I move to the next page?
1 minute, sir.
Okay.
Sir, you can move to the next page.
Sure. So now if tell me that if I'm just plotting a graph, if just I'm plotting a graph, let's say between the number of ejected electrons, right? Let's say here it is the number of ejected electrons, and let's say here it is the intensity. So what type of graph I will get?
Sir, I think
I-
linear.
Yeah, it will be straight linear, that is starting from the origin, right? Isn't it? It will just start from the origin, because I told that the number of electrons ejected, it actually depends on the intensity or the brightness of the light, correct? Okay, now we have seen these two important phenomena. One was the photoelectric effect, another was the black body radiation. But can you tell me here that which metal will actually eject electrons? For example, if I will just say I'm having lithium, sodium, potassium, I'm having rubidium, I'm having cesium or cesium. So can you tell me which will easily show the photoelectric effect?
Sir?
Among these metals, which will easily show the photoelectric effect? That means in which metal electrons will get easily ejected. So actually, bigger the size, more easily can be electrons ejected. So that means here,
Sir.
yes,
Sir, is it rubidium? Rubidium.
no, it is your cesium, last one. It will show easily the photoelectric effect because its size is bigger. For example, in case of lithium, how many shells are there in case of lithium? Its atomic number is 3, so there are only 2 shells. And in case of sodium, there are 3 shells. And in case of potassium, we are having 4. And then here we are having the 5 in case of rubidium. And in case of cesium, we are having 6. So it's having bigger size. So when size is very big, that means electron is actually very far away from the nucleus. So that means it can be easily ejected when light falls on it, correct? Have you got it?
Sir.
So you will just remember that this cesium, or you can call it as cesium, shows highest photoelectric effect, shows maximum photoelectric effect, correct? Maximum photoelectric effect. That means it can easily show the photoelectric effect. That means if we just put small amount of light, electrons will easily get ejected. So if you have to just give the order, so cesium, it can easily show the photoelectric effect, then it will be the rubidium, and then it will be the potassium. Lithium and sodium, they do not usually show the photoelectric effect because their size is small and electron is closely attached to the nucleus. Have you got it? Electron is very close to the nucleus, so that's why that cannot be easily ejected. So this is your cesium, which easily shows the photoelectric effect. Got it?
Sir.
Yes, it actually depends on the metal, nature of the metal. So that is why this cesium, it is used in the photoelectric devices. Photoelectric devices, correct? Photoelectric cells, photoelectric devices, because it can easily show the photoelectric effect and current can be produced, right? So then, okay, shall I move to the next page? Then we have to study the Planck's quantum theory. That's very important. That actually explains the particle nature of electromagnetic radiation. And that Planck's quantum theory actually explains the black body radiation and the photoelectric effect. So shall I move to the next page?
Yes, sir.
Okay. So
Yes, sir.
let me write Planck's quantum theory. Planck's quantum theory. So this Planck's quantum theory, it was just given by Max Planck, right? This Planck's quantum theory, it was just given by Max Planck. In which year? That's 1900 or 1901. Okay, so what this theory actually states, it just gives the particle nature of electromagnetic radiation. So according to Planck's quantum theory, energy is emitted or absorbed. Energy is emitted or absorbed discontinuously. Discontinuously. So in case of electromagnetic wave theory, what we have studied that energy is emitted or absorbed continuously. But here it states that energy is emitted or absorbed discontinuously in the form of small packets of energy. In the form of small packets of energy. Packets of energy known as quanta. So that's why this theory is known as Planck's quantum theory. So this is known as quanta. These are small packets of energy. They are known as quanta. And in case of light, these quantas are known as photons. In case of light, these quanta are known as photons. Got it? So this is the first postulate of this theory. This is very important, that energy is emitted or absorbed discontinuously in the form of small packets of energy known as quanta. And in case of light, these quanta are known as photons. Got it this point?
Yes, sir.
Okay. So now can you tell me here, this quanta, is it singular or plural? Quanta, is it singular or plural? If I'm just talking of this quanta, is it singular or plural? It is plural. So what is it singular? Can you tell me it is singular? It is singular is quantum. So quantum is one and quanta are various, right? Quantum is singular. Have you got it? It's easy to understand. So that's why it is known as Planck's quantum theory. So just as you call, if you are having one photon, so you will just say photon. If you are having various photons, then you just call it as photons. But if you are having one, then it is quantum. And if you are having various quantums, then you call it as quanta. So quanta, it is the plural, it is not the singular. So have you noted down this? Shall I move to the next page?
Yes, sir.
Okay, so this was the first postulate. Now, what is the second postulate? Second is the energy of quantum is directly proportional to its frequency. The energy of quantum is directly proportional to the frequency of light. So that means more the frequency, more will be the energy of quantum. So that means you will simply mathematically write it like this, that is E is directly proportional to the free and to the nu. E is directly proportional to the nu. Now if you just remove this proportionality by some constant, let's say the constant is here very important, that is h. So can you tell me what is this h known as?
Planck's constant.
Exactly, this h is known as Planck's constant. So what is its value? That's very important, you have to remember its value. Planck's constant, so its value is 6.626 into 10 to the power minus 34 joule second. Got it? This is very important. This is very important. Its unit will be, why its unit is joule second? Can anybody tell me why its unit will be joule second? Where from I have got this unit?
It's energy emitted. So
Exactly. We know that E is equal to h nu. So that means h will be equal to E by nu, right? When I told that E is equal to h nu, so that means h will be equal to E by nu. E is the energy. Energy, its unit is joule. And what is the unit of frequency? It is per second, right? And when this per second, it will just come up, it will become +1. So it is joule second. Got it now? This is very important to be remembered here, that h is the Planck's constant and its value is 6.626 into 10 raised to power minus 34 joule second. And so what is the second postulate? That energy of quantum, it is directly proportional to the frequency of light. So have you noted down this? Then there is the third postulate, which we will see on the next page. So have you noted down this? Shall I move to the next page?
Yes, sir.
Okay. So let me write the third postulate of this Planck's quantum theory. That is actually whenever we have any body and it emits the radiation or it absorbs the radiation, that means it will either emit more than one photon or more than one quantum, and similarly it can absorb more than one quantum. So that means, okay, I will write it here, that a body absorbs or emits a body absorbs or emits quanta, or you can say quantum, a body emits or absorbs or emits quantum in the form of some whole number multiple. So have you got this? What I here actually mean? So actually I mean, I have told that E is equal to h nu, right? E is equal to h nu. So that means I can just write that E is equal to n times h nu. So n can be any integer whose value can be 1, 2, 3, 4, etc. Any value it can
sir,
have.
is n the number of packets?
It is simply the number of quantums. Yeah, exactly. Because I told that, see, whenever we have any, for example, we are having sun emits visible light. So tell me, is there only one photon coming from the sun? No, there are billions and trillions of photons are coming. So that means n can have any value. For example, if you are having any bulb, it is just emitting the radiation, so it can emit various number of photons. So that means n can have any number, it can have any value, just like 1, 2, 3, 4, etc. Got it? Yes. So that means a body absorbs or emits quantum in the form of some whole number multiple. I hope you understand this whole number multiple, right? So for example, if any body is not emitting any radiation, so that means at that time n value will be 1, n value will be 0 at that time, because it's not emitting or absorbing any radiation, right? Okay, now here it's very important point that tell me that if n value is equal to Avogadro number, if n value is equal to Avogadro number, so at that time what we call it as? We call it as E is equal to Na Avogadro number into h nu, right? And this is known as 1 Einstein of energy. It's known as 1 Einstein of energy. Got it? When n value is equal to Avogadro number, I hope you know the Avogadro number, that's 6.022 into 10 to the power 23, right? So if we are having Avogadro number of photons or the quantum just coming from any body or any substance, so at that time we just call the energy as 1 Einstein of energy. So got it now? So these are the three important postulates of Planck's quantum theory. So the first postulate was that energy is emitted or absorbed discontinuously in the form of small packets of energy known as quanta. And in case of light, they are known as photons. Then the next postulate that is very important, that is energy of quantum, it is directly proportional to its frequency. And the third is that whenever any body emits or absorbs the radiation, so that means it do it in the form of some whole number multiple. That means either it will, let's say n value, it can be 1, 2, 3, 4, etc., any value. But if n value is Avogadro number, at that time we call it as 1 Einstein of energy. So have you got it? Shall I move to the next page?
Yes, sir.
Okay, now tell me here that, for example, if I will just write, so a Planck's quantum theory, mathematically, it can be just written as like this, that is E is equal to h nu, right? Now tell me, you know that nu is equal to c by lambda, correct? You know that nu is equal to c by lambda. So what will be the equation next? That is E is equal to h c by lambda, correct? Isn't it? Have you got it? Okay,
sir.
next.
Yes,
Next
sir.
is, you know that wave number. Wave number is equal to 1 by lambda. So that means in place of this 1 by lambda, what you can write? You can write h into c into nu bar, that is wave number. So these all equations are very important. I hope you will remember. So these are three equations. One is E is equal to h nu. It is the first. It is the first. Another is E is equal to hc by lambda. It is your second. And third is E is equal to hc into nu bar. This is the third equation. So got it? This is very important. I hope you will remember it. So that means if frequency is given to you, you can just calculate its energy. And that's why I told that when energy is directly proportional to the frequency, so if frequency is very high, energy will also be very high. And if frequency is very low, so that means energy will also be low, correct? Are you getting? And similarly, you will remember that energy is inversely proportional to the wavelength. So that means if wavelength is very less, then its energy will be very high, correct? And similarly, energy is directly proportional to the wave number. That means higher the wave number, higher will be the energy. These are the very important conclusions from the Planck's quantum theory. I hope you have got these three very important conclusions, right?
Environment.
Isn't it? Yeah. So for example, if I will just tell you that if I'm having, let's say, any electromagnetic radiation, and let's say the wavelength is given to you, that is 100 angstrom. So can you tell me what will be its energy? It is now very easy to calculate the energy from this Planck's quantum theory. I hope you can do it. So can you calculate energy? Which formula you will apply, first, second, or third? Can you tell me here which formula? This is your first, that is E is equal to h nu. This is second, E is equal to hc by lambda. This is the third, E is equal to hc into nu bar. Which formula you will apply here?
Second.
Second one, exactly, because energy is equal to hc by lambda. So have you calculated the answer? Can you follow this one? It is easy. So first you will write the Planck's constant, that is 6.626 into 10 raised power minus 34 joule second, right? And then you will just multiply it with c. C is the speed of light, that is 3 into 10 raised power 8 meter per second, right? And then you will just divide it by lambda. Lambda is your wavelength. Wavelength is 100 angstrom. So can you tell me 1 angstrom is how much?
10 per minute.
So can you write it like this, 100 into 10 to the power minus 10 meter, right? So you will just, okay, now can you tell me 100? Can you write in place of 100, can you write 10 raised power 2? Yes, we can. And it's 10 raised power minus 10. So it will become 10 raised power minus 8 meter. So I will write simply 10 raised power minus 8 meter. Yeah. Have you got it? Any doubt here? It is simple.
No doubt, sir.
Now, okay, meter and meter, it will just get cancelled. Then I hope you can easily solve this. Now it is second raised power 1. Here it is second raised power minus 1. So when base or some power should be added, so it will also get cancelled. So unit will be in joule because we are having energy. So energy unit will be joule. So have anybody solved this? What will be the answer? Anybody's? Have anybody solved this?
Sir,
Yes, sir.
19.878 into 10 power minus 18.
10 to the power minus?
18.
Okay, let's see.
Minus 18.
Yes, minus?
Minus 8.
Okay, so let us see, no problem. It was, what was this? It was here energy was 6.626 into 10 to the power minus 34. It will now just come it in joules. Then the next was speed, that is 3 into 10 raised power 8 meter per second. So meter and second, they have already got cancelled. And then it is divided by lambda. Lambda was 10 raised power minus 8. When it will just come up, it will become 10 raised power plus 8, right? So the approximate answer, it will be just like this, that is 19.8 into 10 to the power. So what will be the answer? So 8 and 8 here. So we have just what I had it, 6.626. I have multiplied it with 3. And then when base or some power should be added, so it is 16, 10 raised power 16, and it is now minus 34. So what will be the answer?
Sir, minus 18.
Minus 18. Exactly, it will be in joule. So have you got it?
Sir.
Okay, so then let's recap what we have studied in today's class. So just we have started with the electromagnetic wave theory, and we know that C is equal to nu into lambda. That means you can solve questions on this. That means you can calculate the frequency and you can also calculate the wavelength, right? And then we have solved some questions on that. And then we just move towards the two very important phenomena, that is the black body radiation and the photoelectric effect, which can only be explained on the basis of particle nature. And that particle nature was actually given by Max Planck, Planck's quantum theory. So what was black body? I told that any such body which will emit and absorb radiations of all frequencies or radiations of all wavelengths. Can you hear me?
Yes, sir.
Where are you?
Sir.
Are you here in the class?
Yes, sir.
Yes, sir.
Then why you are not concentrating? You are just discussing there.
No, sir. Doubt discussion.
Okay, I was just saying that black body is any such body which will just emit or absorb radiation of all wavelengths or frequencies. Then I just give one of the example, that is, if iron rod, it is just heated, it changes its color, and it can be explained only when you just consider the particle nature. If you just consider the wave nature, on the basis of wave theory, we cannot explain that why it is changing. According to wave theory, it should emit only one color, but it is changing its color. Why it is so? So it can be only explained when we just take the Planck's quantum theory. So yeah. So next, what I told, that is the photoelectric effect. I told that it is actually such a phenomena in which electrons are ejected from the metal surface when light falls on that. And it is the cesium which shows very high photoelectric effect. That's why it's used in photoelectric devices. And the four important points, I hope you remember. One was what? One was the electrons are ejected as soon as light falls on it. And next was that the kinetic energy is directly proportional to the frequency. Next was the intensity. It affects the number of photoelectrons. That is, number of photoelectrons ejected, it depends on the intensity. And the next was what? Next was that electrons will be ejected only if light has some minimum frequency, and that is known as threshold frequency, right? And then we studied about this Planck's quantum theory given by Max Planck. It's three very important main postulates. They were that whenever energy is emitted or absorbed, it is always emitted or absorbed in small packets known as quanta. And in case of light, these are known as photons. Photon is one, and photons are the plural, that's various. And quantum is one, and the quanta are various, that is plural. Okay, then I told that the energy of this quantum, it is directly proportional to the frequency. And the next I told that whenever a body emits or absorbs the radiation, that is always emitted or absorbed discontinuously in the form of some whole number, multiple quanta, that is E is equal to NH nu. And I told that if N is Avogadro number, then it is known as 1 Einstein of energy, correct?
Sir.
Yeah, so we have completed this Planck's quantum theory. In the next class, we will just solve some numericals on this, and we will also explain the photoelectric effect and the black body radiation with this Planck's quantum theory. So any doubt, any question?
Yes, sir. No, sir.
Each and everything clear?
Yes, sir.
Okay. So let's stop then today's class here. Wish you all the way best. Have a nice day ahead.
Thank you, sir.